All right, let's start messing around with some bounds. So here is our formula now. It's the same thing, except we have to evaluate. When we get our u times our v, we actually have to evaluate our bounds from a to b. And then we get our v to u, and then we'll just deal with the bounds as per normal. But I think it's probably a little bit simpler just to see the problem in action. So here we go. Let's deal with inverse tangent of x. So we're going to begin just the normal way. We got to find a u. I think that would be a good u. And I think this right here would be a good dv. Okay, so u is equal to inverse tangent of x. And our dv is equal to dx, or 1 times dx. So du is equal to 1 over 1 plus x squared dx. And our v is just equal to, the antiderivative of 1 is just x. All right, so now we got to do our u, v minus v du. So there we go. So we're like, all right, so u times v. So we got our u times our v. That's x times inverse tangent of x. But we have to evaluate it now from 0 to 1. Minus the integral from 0 to 1 of our v du. So that's x times 1 plus x squared dx. Hey, u sub. Unfilled u sub. So let's just deal with the left-hand side for now. We'll deal with that integral in a second. All right, so we need to plug in 1. So we get 1 times inverse tangent of 1. Oh, that's simple. 0 times inverse tangent of 0. So 1 times inverse tangent of 1, that's clearly pi over 4. We all know that. 0 times inverse tangent of 0, that's 0 times 0, so that's just 0. So we end up with pi over 4 minus the integral from 0 to 1 of x over 1 plus x squared dx. Well, the by parts is done. Now it's just, hey, do you remember how to do u subs? Yeah, so let's take that denominator and call it u. 1 plus x squared. Du is going to be 2x dx. But we need to replace with an x dx. So we'll divide out the 2, and we're left with x dx. Cool. So we have pi over 4 minus the integral. So what do we end up with? So our u becomes the denominator, and then our x dx becomes 1/2 dx. But we need to change our bounds, right? We got to change our bounds. So when x is equal to 1, we get 1 plus 1 squared, which is 2. Okay. When x is equal to 0, we get, 1 plus 0 squared, which is equal to 1. Okay. Now we can take that, where did I write dx? I must be looking at that going, what the hell's wrong with that guy? There's a lot wrong with me. All right, so it's that 1/2 du. There it is. So now we can go and take our next step. The antiderivative of 1 over u is the natural log of the absolute value of u, but I'm not using the absolute value because we're plugging in 1 and 2. So what do we have? Pi over 4 minus the integral of 1/2 ln of 2 minus 1/2 ln of 1. And we all know ln of 1 is equal to 0, right? We know that. Come on. So it's pi over 4 minus 1/2 ln of 2. That looks like a pretty sufficient answer. Know what I mean? That looks pretty sufficient. If you wanted to get really crafty with it, you wanted to act like you were a badass. And I won't explain why. Hopefully you see that. But yeah. That's how we deal with bounds. It's really just the first step. All right, it's that first step, evaluating it. It's not much tougher than what we'd normally do, and there's no plus c because we're using bounds. So either one of these answers is perfectly sufficient. But I would like you to think about, like, why is that? 1/2 ln of 2 is just ln of the square root of 2? Think about it. All right, that's it. Oh, see, we'll just start dealing with, I believe it's trigonometry next. Yeah, hey, your teacher likes trigonometry. I'll be bringing the heat. All right, see ya.